Hello and welcome again. This is your host Harshit Sinha, continuing from my previous presentation on e-waste and now exploring the most important challenge in the growing economic battery waste management. Today, battery waste management in India is crucial for environmental sustainability and public health. With the rapid increase in the battery usage of electric vehicle, and renewable energy system, effective management of battery waste has become a significant challenge. The significance of battery waste management lies in its ability to reduce environmental pollution and conserve the natural resources. Proper disposal and recycling of the batteries prevent toxic substances like lead, cadmium, and lithium from leaching into soil and water, thereby protecting ecosystem and human health. Additionally, recycling batteries help recovering valuable materials, reducing the need for new raw material and promoting a circular economy. However, there are several challenges associated with the battery waste management in India. Informal and unregulated recycling practices poses significant environmental and health risks. Many small-scale operations lack the necessary infrastructure and technology for safe disposal and recycling, leading to hazardous consequences. Lack of awareness among consumers about the proper disposal method for batteries further exacerbates the problem. Limited infrastructure and technology for recycling different types of battery, especially lithium-ion batteries, also hinder efficient recycling efforts. Now let us explore the topic with a focused narration. The growing concern in the battery waste management is because of the exponential growth in the battery usage and subsequent waste generation presents multiple interconnected challenges. First, the rapidly growing electric vehicle market is significant trends in the global push towards a sustainable transportation. In 2023, electric car sales reached nearly 40 million, a 35% increase from the previous year. This surge is driven by the needs to reduce the greenhouse gas emission and dependency on the fossil fuels. However, the rise of EV adoption also brings challenges, particularly in managing the increased battery waste generated. Electronic devices, including EV batteries, contain critical raw materials such as lithium, cobalt, and nickel. These materials are essential for the battery production but are finite and often sourced from the environmentally sensitive area. Recovering these materials from spent batteries presents a significant opportunity to reduce the environmental impact of mining and ensure sustainable supply chain. Proper recycling and recovery can also mitigate the hazardous material in electronic waste such as arsenic, cadmium, lead, and mercury, which pose serious health risks if not managed correctly. Second, environmental protection is a crucial aspect of managing electronic waste. The improper disposal of e-waste can lead to soil and water contamination, affecting both ecosystem and human health. Implementing stringent recycling regulations and promoting extended producer responsibility, that is EPR, can help address these issues. EPR policies hold manufacturers accountable for entire life cycle of their product, encouraging them to design more sustainable and recyclable products. The third is related with the employment generation through the formal recycling sector also play a vital role in tackling the growing demand for electronic device and associated waste. Recycling not only conserves valuable resources but also generate employment opportunity. As the recycle industry expands, it's creates a job in collection, sorting, and processing of e-waste, contributing to economic growth and social well-being. In conclusion, the rapid growth of EV market and electronic device usage necessitate effective strategy for managing battery waste, recovering critical raw material, protecting the environment from hazardous material and generating employment in the formal recycling sector. By addressing these challenges, one can move towards a more sustainable and circular economy. The informal sector plays a significant role in e-waste management in India, handling a substantial portion of the country's e-waste. However, this sector faces several challenges, including unorganized collection, hazardous practice, and integration challenges. First, unorganized collection. The informal sector often relies on unorganized collection methods where waste is gathered from households, businesses, and other sources without proper documentation or regulation. This can lead to inefficiencies and missed opportunities for proper recycling and disposal. Second, hazardous practice. Informal recycling often involves unsafe and environmentally harmful practice. Workers in the informal sector frequently dismantle e-waste using primitive methods, exposing themselves and the environment to toxic substances like lead, mercury, and cadmium. These practices pose a serious health risk and contribute to environmental pollution. Third, integration challenges. Integrating the informal sector into formal e-waste management systems presents several challenges. Informal workers often lack access to proper training, technology, and resources needed for safe and efficient recycling. Bridging the gap between the informal and the formal sector requires a capacity building, policy support, and collaborating to ensure that informal workers can transition to safer and more sustainable practice. Efforts are being made to address these challenges, such as providing a legal recognition to informal workers, offering training programs, and developing framework for collaborating between formal and informal sectors. These initiatives aims to improve e-waste management practice and reduces the environmental and health impact associated with the informal recycling. Now this slide describes the type of batteries waste and its composition. Battery waste encompasses various types of each with a distinct composition and recycling challenges. Here are some common type of battery waste and their composition. First, lead acid battery commonly used in the vehicle and backup power system. These batteries contain lead, lead dioxide and sulfuric acid. Lead acid batteries are highly recyclable with nearly 90% being recycled. Second, lithium-ion batteries found in the smartphone, laptops and electric vehicle. These batteries contain lithium, cobalt, nickel and other metals. Recycling lithium-ion batteries is crucial due to the high value and environmental impact of their components. Third, nickel cadmium batteries used in the power tools and emergency lighting. NICD batteries contain nickel hydroxide and cadmium. These batteries are recyclable but pose environmental risk due to cadmium toxicity. 4. Nickel metal hydride batteries. Common in hybrid vehicles and rechargeable house device, NIMH batteries contain nickel and rare earth metal. Recycling these batteries helps recover valuable material. Fifth is alkaline battery. Widely used in household devices like remote control and toys, alkaline batteries contain zinc and manganese dioxide. While not typically recyclable, proper disposal is essential to prevent environmental and contamination. 6. Zinc carbon batteries found in low drain devices like clock, flashlights, and these batteries contain zinc and manganese dioxide. Recycling zinc carbon batteries helps recover zinc from reuse. Lastly, we can say that proper management and recycling of the battery waste are essential to prevent environmental pollution and recover valuable material. Recycling but these involve collecting and used battery, sorting them by type and extracting metal for reuse. This not only conserves the natural resources but also reduces the environmental impact of mining and manufacturing new batteries. Now we shall discuss about the regulatory framework associated with battery waste to the renewable potential. The evaluation of the battery, either known as management and handling rules in India, reflects the country's growing commitment to environmentally sustainability and responsible waste management. Initially introduced in 2001, the battery waste management and handling rules were aimed at regulating the collection, storage, transportation, and disposal of used lead acid batteries to minimize the environmental impact. In 2022, the Ministry of Environment, Forest and Climate Change introduced the battery waste management rules replacing the 2001 regulation. These new rules emphasize extended producer responsibility, that is EPR, making producer responsible for collection and recycle of waste batteries. The rules also introduce a centralized online portal for the exchange of EPR certification between the products and recyclers. The battery waste management rules were further amended in 2024 to address the increasing volume of the battery waste due to the rise of the electronic device, electric vehicle, and renewable energy system. The amendments include stricter recovery targets, mandatory reporting, and enhanced enforcement mechanism to ensure compliance. The key changes introduced by the new rules is concerned with the 2 points. One is related to provisions of certificate for the battery where, as per 2022 rules, extended producer responsibility certificates will be generated by the Central Pollution Control Board through the centralized online portal based on the recycled and refurbished quantities and assigned to recycler or refurbishers. It emphasized to sell assigned EPR certificate to the producer in exchange of waste battery, while in 2024 the CPCB shall fix the highest and the lowest price for EPR certificate. It shall be equal to 100% and 30% respectively for the environmental compensation leviable on the obligated entities for non-fulfillment of EPR obligation. The exchange price of EPR certificates between registered entities through the portal shall be between the highest and the lowest price. The second is related with the action on violation and imposition of the environmental compensation. Here in 2022, Committee for Implementation, constituted by the Central Pollution Control Board, shall prepare and recommend guidelines for imposing and collection of the environmental compensation from producer and entities involved in recycling of waste batteries for non-compliance of rules. The recommended guidelines shall be submitted to the Ministry of Environment, Forest and Climate Change. While progressively in 2024, the CPCB will prepare and recommend these guidelines. The CPCB may consult the Committee for Implementation for the same. Recommended guidelines shall be submitted to the Ministry. Overall, these involving regulation underscored India's efforts to promote circular economy and reduce environmental footprint of battery production and disposal. Extended producer responsibility (EPR) is a policy approach where the manufacturer bears the responsibility to the entire life cycle of their products, including disposal and recycling. In the context of the battery waste, EPR mandates the producer to ensure environmentally sound collection, recycling, and disposal of used batteries. First is related to the principle. EPR emphasizes sustainable practice by holding producers accountable for minimizing the environmental impact of battery waste. This includes designing recyclable product, financing collection system, and facilitating recycle process. Second is related to implementation. India's Battery Waste Management Rule 2022 introduced EPR for the battery producer. They must collect a specified percentage of end of life batteries through former channels and ensure their recycling or safe disposal. Producers are required to file complaints report and work with the authorized recycler to recover critical raw material like lithium, cobalt, and nickel. Incentivized buyback program and deposit refund scheme are also encouraged to promote battery collection. Third is related to what are the challenges associated. The key challenges include lack of organized collection infrastructure, limited recycling facilities, and integrating of the informal recycler sector, which dominate the battery waste landscape, high cost of the recycling technology, and insufficient awareness among the consumer further hinder the EPR implementation. Moreover, the enforcement of the complaints across small scale manufacture remains a significant hurdle. Now let us look public awareness and participation in this regards. Public awareness and participation are critical for effective managing battery waste and reducing its environmental impact. Educating citizens about the hazards of improper battery disposal and the benefits of recycling is the first step towards the fostering responsible behavior. Awareness campaigning, workshops, and a school program can highlight the environmental risks of hazardous materials like lead, lithium, and cobalt leaking into ecosystem. The second is incentivize gain further can encourage public participation in the battery waste management. Government and the business can introduce schemes like cashback discount of credit for returning used batteries to designate collection points. Extended producer responsibility framework often mandates the producer to provide convenient take back option and reward system to engage consumer community participation. It is essential for creating robust collection network. Citizens can contribute by segregating used battery, ensure their proper disposal, and supporting authorized recycle initiatives. Collaborations with local self-help groups, NGOs, and informal sector workers can expand outreach, particularly in underserved regions. Overall, effective battery waste management required consistent efforts to raise awareness, build trust in recycling system, and ensure transparency in operation. Empowering public through education and incentives can transform them into active stakeholders in achieving sustainable circular economy. Now we shall discuss about the role of stakeholders. Battery waste management requires active collaboration between the key stakeholders, including governments, industries, consumers, communities, and research institutions. The government plays a central role by formulating policy, enforcing regulations like extended producer responsibility (EPR), and providing financial incentives for sustainable battery management. It also invests in public awareness campaigning to promote proper disposal and recycling practice. Industries, especially battery manufacturers and recyclers, are critical in adopting sustainable production methods and establishing recycling infrastructure. They design batteries for easier recycling, implement take back program, and invest in eco-friendly technology to minimize waste and environmental harm. Consumer and communities are vital participants as their awareness and action directly influence waste collection and segregation. Public education campaigning, incentives for proper disposal, and active community participation in recycling programs are significantly improve waste management outcome. Research and academia contributes by developing innovative recycling technologies and sustainable battery design. They analyze environmental impact and provide data-driven insight to shape policy and industrial practice. Collaboration with the industries ensure that cutting-edge solutions are implemented effectively. By working together, these stakeholders can create an integrated, efficient battery waste management system that safeguards the environment and optimizes the resource recovery. Technological advancement are pivotal in addressing the challenges of the battery waste management, focusing on recycling technology, battery design, and alternative chemistries. Recycling technologies has evolved significantly to recover valuable materials like lithium, cobalt, and nickel. Innovative processes such as hydrometallurgy and psychometrology methods enhance material recovery rates while minimizing the environmental harm. Emerging techniques include direct recycling, promises even higher efficiency by preserving battery components to reuse. Battery design is another area of progress where, with the manufacturer increasingly adopting design for recyclability, the principle modular battery design and easy to disassemble components streamline the recycling process, reducing cost and energy consumption. Alternate chemistries are being explored to minimize dependency on the critical raw material. For example, lithium-ion phosphate batteries, which uses less cobalt and nickel, offer a more sustainable option. Sodium-ion batteries are getting attention as a cost-effective alternative due to abundance of sodium. These advancements not only reduce the environmental footprints of the battery but also create economic opportunities in recycling and material recovery. However, challenges such as scaling these technologies and ensuring global adoption remain. Investments in R&Ds and collaborative efforts among the government, industries, academia are essential for the widespread implementations. Now we shall discuss about the economic opportunities in this regard. Battery waste management presents a significant economic opportunity by leveraging resource recovery, job creation, and circular economic principles. Resource recovery from a used battery is a critical driver of economic potential. Advanced recycling technology enables the extraction of valuable materials like lithium, cobalt, and nickel. With the global demand for these critical raw materials surging, efficient recovery can reduce dependency on imports and stabilize supply chain, offering cost advantage to industries. Job creation is another substantial benefit. The establishment of the formal recycling facilities and collection network generate employment across skill levels, from material handling and processing to research and development. Battery waste management fosters a range of job opportunities, particularly in regions where the growing electric vehicle and electronic market. Incorporating circular economy principle into battery waste management ensure resources remain in use for as long as possible, enhancing the economic efficiency. Businesses adopting closed-loop recycling system can reduce raw material cost while boosting sustainability credential attracting environmentally conscious consumers and investors. Despite of these opportunities, challenges like high initial investment, inadequate infrastructure must be addressed. Collaborative efforts between the government, industries, and the communities are essential to maximize the economic benefits and ensure the sustainability of the battery management system. Now we shall discuss about the challenges and barriers in the battery waste management. The effective management of the battery waste is hindered by numerous challenges and barriers such as inadequate infrastructure, limited awareness, regulatory enforcement issues, and the financial constraint. Lack of infrastructure is pressing in many regions. Efficient battery waste collection, transportation, and recycling requires specialized facilities and logistic network, which are often underdeveloped or absent. The gap leads to significant volumes of battery waste ending up in a landfill or informal recycle sector, causing environmental damage. The limited awareness among the consumer business and informal collectors exacerbate the problem. Many people are unaware of the environmental hazard posed by the improper disposal of the benefits of recycling. This knowledge gap reduces participation in the formal waste management initiatives and perpetuates unsafer practice. Regulatory enforcement poses another major barrier, while the policies such as the batteries management and handling rule in India outline procedure for managing battery waste. Enforcement remains weak due to insufficient monitoring, limited accountability, and inadequate penalties for non-compliance. As a result, many stakeholders disregard their obligations. Financial constraints significantly hinder progress establishing and maintaining recycling infrastructure. Implementing awareness campaigning and forcing regulation requires substantial investment. The high cost of recycling technology and uncertain returns on the recovered material discourages private sector involvement. Overall, if we see, addressing these challenges demands a multi-pronged approach. Government must prioritize the investment in the infrastructure and offer financial incentives to encourage industry participation. Public awareness campaigning can foster community involvement, while the stricter enforcement mechanism can ensure compliance with the regulations. Collaborative efforts among the stakeholders, including the private sector and the civil society, are crucial for overcoming these barriers and fostering sustainable batteries waste management. Now let us look best practices and success story in the waste battery management. Battery waste management has seen significant advancement through effective practice such as lead acid battery recycling, collection and take back program, and public private partnership offering valuable insight into sustainable solution. Lead acid battery recycling is a notable success story. Globally, over 95% of the lead acid batteries are recycled, making it one of the most effectively recycled products. Countries like the United States and Japan have established robust systems for collection, dismantling, and material recovery, minimizing environmental risk while ensuring the supply of the critical raw material like lead. India has also implemented successful lead-acid battery recycling framework under the Battery Management and Handling Rule of 2001. Collection and takeoff program implemented by the industries and the government have proven to be vital. For example, companies like Tesla and Apple have initiated take-back schemes encouraging consumers to return used batteries for proper disposal or recycling in India. In India, extended producer responsibility mandates have encouraged the manufacturer to set up collection centers and collaborate with the authorized recycler, improving the battery recovery rates. The public private partnership have also demonstrated immense potential. For instance, partnership in European Union such as Recharge initiative brings together government, industries and research institutions to promote innovative recycling technology and sustainable battery management. Similarly, in India, initiatives like Swachh Bharat Abhiyan have fostered collaboration between the public authorities and the private waste management firm to address the growing battery waste challenges. The key to these success lies in the stakeholder collaboration, strict enforcement, policies, and community participation. Promoting these best practices on global scale can help address the challenges posed by the rising demand of the batteries and subsequent waste. Now let us explore the future outlook of the battery waste management in India by 2024. The future outlook for battery waste management in India by 2024 is a promising yet challenging. The rapid growth of electric vehicles market and the increasing use of the electronic device have led to a significant rise in the battery waste. To address this, the Indian government has introduced stringent regulations and amendments to promote sustainable practices. The Battery Waste Management Amendment Rule 2024 set an ambitious target for the use of the recycled materials in the battery production. These rules mandate minimum percentage of recycled material in various types of batteries, aiming to conserve resources and reduce environmental impact. The implementation of these regulations is expected to drive innovation in recycling process and encourages manufacturers to adopt eco-friendly practices. The key development shaping in 2024 outlook is related with the extended producer responsibility framework. Under these rules requires manufacturers and importers to collect 90% of the waste portable batteries by 2027. This stage implementation began with a lower target in 2024, pushing companies to establish collection network. Another is related to Indian electric vehicle battery market is expected to create substantial waste volume. The government estimates that by 2025, about 128,000 tons of electric vehicle battery will reach to end of life, emphasizing the urgent need for recycling infrastructure. The third is initiative taken. Several initiatives are emerging, such as major battery manufacturers are establishing recycling facilities, urban local are creating dedicated battery collection point, digital waste management platform are facilitating collection and tracking, and public-private partnership are developing recycling technology. However, the challenges remains particularly in integrating the informal sector into the formal recycling. Informal recycler who handles a significant portion of the used battery often lack the necessary infrastructure and technology for safe disposal and recycling. Efforts to provide training and resources to these workers are crucial for improving overall waste management practice. Additionally, raising public awareness about the proper battery disposal and the importance of recycling is essential to ensure compliance with the regulations and reduces environmental pollution. The government commitment to promoting circular economy and reducing the environmental footprint of battery production is a positive steps a more sustainable future. Now, here we end the topic presentation. Before we move up to the next type of waste, let us recall what we have covered in the topic. We started the presentation with the introduction of navigating future responsibility for rising battery waste to renewable potential and explained the growing concern with what are informal sector involvement in the battery waste management. Continuing, we explore the type of battery waste and its composition and how the regulatory framework have evolved over the years. This is followed up with the explanation on how extended producer responsibility is attached to it and how public awareness and participation could lead to solve this mess in e-waste. Continuing from this, we explain the role of stakeholders, technological advancement, economic opportunities, challenges and barriers, and the best practices with success stories. In the end, we explored the future of battery waste management in India by 2024. Now we shall dive into the next type of interesting waste on one of the most challenging industrial hazard waste management, a constant challenge for India. At the end, I wish you a Merry Christmas and Enjoy the Christmas vacation. Thank you very much. Bye bye.